In today's video, we are going to discuss about subsets and intervals. Before starting that, we need to know what a subset is. So, for example, let us take set A, which consists of all the natural numbers till 20. Let us take another set B, which consists of the elements 2, 4, 6, 8, 10, and a set C, which consists of the elements 2, 4, 9, 16. Now we can see that both the sets B and C consists of elements which can be taken from the set A. In simple words, we can say that every element of B is also an element of A, and similarly every element of C is also an element of A. Since both the sets B and C consists of elements which are taken from the set A, so we can say that B and C are subsets of A, which is written as B as a subset of A and C is a subset of A. In the same manner, since A consists of all the elements which are present in its subsets B and C, so we can say that A is the superset of B and C, and we can write it as A is the superset of B or A is the superset of C. Now there are two types of subsets. First is known as the proper subset. So imagine two sets A and B such that A is a subset of B, but A is not equals to B. Then A is known as a proper subset of B and we write A is a subset of B. For example, let us say B is equals to 1, 2, 3, 4, 5 and A consists of the elements 1, 2 and 5. So the elements of A is taken from the set B, but A and B are not equal. So we can say that A is a proper subset of B. However, the second type of subset is improper subset. If there are two sets A and B such that A is a subset of B and A is equal to B, then we say that A is an improper subset of B and we write it as A improper subset B. So for example, let B be a set 1, 2 and 3 and A be a set which also consists of the elements 1, 2 and 3, not necessarily in the same order. Since A and B consists of the same elements, or we can also say that the elements of A is taken from the set B, so A is a subset of B, but since A and B are equal sets, so we write it as A is an improper subset of B. Now there are a few things you have to note in case of subsets. The first thing is every set is a subset of itself. That means every set A is an improper subset of itself. The second thing is the empty set is a subset of every set, so phi is a proper subset of any set A. The third thing is a set which consists of n elements has a total of 2 to the power n subsets. So for example, a set A has n elements, or the cardinality of the set A is n. Then the number of subsets it will have is 2 to the power n. This can be easily demonstrated using an example. Say for example, we take a set A equals to 1, 2, 3. We first write all the subsets, both improper and proper, which can be derived from this set. So since empty set is a subset of every set, so the first subset will be phi. Now taking one element from the set A, we get the subsets 1, 2 and 3. Taking two elements at a time, we get the subsets 1, 2, 2, 3 and 1, 3. And now taking three elements at a time, we get the subset 1, 2, 3. Out of which all these subsets are proper subsets and this one is an improper subset. So we can see that the cardinality of the set A was 3 and the total number of subsets this set has is 8, which can be derived from the formula 2q. Now imagine if there are some sets under consideration, say A, B and C, and there happens to be a set A which is the superset of each of these given sets. So for example, let us take that set as U, where U is a superset of A as well as B as well as C. In such a case, the set U is known as the universal set. So the universal set is a set consisting of all the elements which are present in a given set. For example, if A equals to 1, 2, 3 till 10, B is a set consisting of all the even numbers till 24, and C is a set consisting of all the prime numbers till 20, then we can take the universal set as all the natural numbers till 30. In this example, we can see that A, B and C, all these three sets under consideration is a subset of the given set U. So we can denote U as the universal set of these three sets. A more common example is in case of subsets of real numbers, where the set of natural numbers, the set of whole numbers, the set of integers, the set of rational numbers, these are all subsets of the set of real numbers. So we can say that real number is the universal set, and the set of natural numbers, whole numbers, integers, and rational numbers are all subsets of the universal set R. Now, when we are talking about subsets of the real set, sometimes the subsets of real sets are also denoted as intervals. Now, talking about subsets of R, we shall now describe subsets of R not in set builder form but as intervals. So, intervals are infinite sets which are not written in set builder form, which are subsets of R, in which the upper limit and the lower limit of the values of the sets are written within brackets. There are four major types of intervals. Let us first consider two elements from the set of real numbers, say A and B, such that A is less than B. The first type of interval is known as a closed interval. So a closed interval is denoted as A comma B written within square brackets. This denotes the set X such that X is an element which is less than equals to B and greater than equals to A. In the number line, it can be represented as such, where A and B are first represented by darkened circles, since X can attain both the values A and B, and all the elements between A and B are also present inside the interval, so that entire line is darkened as well. The next type of interval is known as an open interval, in which the upper limit and lower limit of the set are written within the first bracket. This set in the set builder form can be represented as X such that A less than X less than B. So this set consists of all the elements present between the real numbers A and B, but excluding the values A and B. In the number line, this can be represented as A and B, which is put in open circles, and since all the elements present between A and B are present inside the set, so the line between A and B is darkened. The third type of interval is known as a semi-open or semi-closed interval. This consists of two types of intervals. The first is known as the right half open interval, denoted as such or such. This consists of the elements X such that X is an element which is either greater than equals to A but less than B. So X can attain the value of the lower limit but not the upper limit. In the number line, this is represented as such, where A is put in a darkened circle and B is put in an open circle, since A is a value which X can attain and B is a value which X cannot attain. And the second type of semi-open or semi-closed interval is denoted as such, which is also known as left half open interval. This consists of the set of elements which is greater than A but less than or equal to B. So in this case, X can attain the value of the upper limit but not the lower limit. In case we represent this set in the number line, this can be represented as such, where B is put in a darkened circle, A is put in an open circle, and the distance or the line between A and B is darkened. So this represents all the elements which are present between A and B, in which B is included but A is not included. Now suppose A is a set containing of the numbers 2, 3 and 5. Then all the subsets of this set will be 5, 2, 3, 5. Now taking two elements at a time. Now writing the improper subset of the given set. If we now put all these subsets in another set, then this set is known as the power set of A. So a power set is a set of all the subsets of a given set. Since if a set has n number of elements, the total number of subsets is 2 to the power n. So if a set A has n number of elements, then the power set of that set should consist of 2 to the power n elements. Now one thing to note here is, if we now make a subset of the power set of A, then those subsets will be written as starting with 5. Now if we take one element at a time, we first have to take 5 and put it in a set. So the first subset will be subset 5. The second subset will be taking this element and putting it in a set. So the second subset looks something like this. The third subset will be taking this element and putting it in a subset. This will continue till we take all the elements from the power set of A, taking one at a time, then taking two at a time, then taking three at a time, and so on. So taking two at a time, the subset will be 5 and set 2 put in a set, then taking the sets 2 and 3 and then putting them in a set, then taking the set 3 and 5 and putting them in a set. This will continue till all the elements from the power set of A is taken and put in a set.